Okay, so we are graphing y equals the log of x base 2, and we're going to look for its key features. So this is not it. This is a function that we're going to do a little bit later. To put this in, you're going to go right on line 1 and do math, alpha, math. This allows you to put the base in of 2, and the x will be the argument. So go ahead and graph that on a standard window by hitting zoom 6. And this is the picture that you should see. So this is your basic log function with base 2. If you change that base to another number, it'll change what the graph looks like slightly, but it won't be dramatic. The only dramatic change you would see is if that base was something like 0.5 or 3/4 or 0.99. Any number between 0 and 1 would make it change dramatically, and we'll see that when we get to the one try it problem. But no matter what the base is, the parent function would have the following key characteristics. The domain is all positive numbers from 0 to infinity. As you can see, this graph is not hopping over the y-axis, over to the left side. It's only going to hit x values that are positive. The range, on the other hand, is all real numbers. And if you recall our study of exponential functions, the domain and range are flip-flopped. 2 to the x power looked like this. The log of x base 2 is the red one. By the way, this graph does continue to drop down like this and go towards negative infinity. It's just that the graphing calculator has a little bit of a tough time drawing that portion of it. All right? So the blue function that I've drawn here is y equals 2 to the power of x. The red one is the log of x base 2. These are inverses of each other. What I was getting at is that the domain and range of the red function are the opposite, or flipped, because they're the inverse, of the blue function. For the blue function, the domain would be all real numbers, and the range would be positive numbers, anything greater than 0. Okay, they also wanted the x-intercept of the red function, and that's right here at 1, 0. That will be the x-intercept of every parent function for logs, whether the base is 2 or 10 or e or a fraction. You'll always have an x-intercept of 1, 0. That's because the log of 1, no matter what the base is always 0, because that base to the 0 power is always 1. All right, so that x-intercept will be in common. Now, what else did we want? The asymptote, that's right. So this has a vertical asymptote, the red graph, right here. It is the y-axis. So the asymptote would be x equals 0. Whereas the blue function had a horizontal asymptote at y equals 0. So as you can see, everything from the exponential world is flip-flopped to the log world. They are inverse operations, so everything's going to be flipped around. Finally, let's talk about end behavior, EB. Well, for the log function, which is what we were asked to do, as x goes to the right and gets very positive, so as we're going this way on the graph, the y will continue to rise as well. So your y is going to go to infinity. For the behavior as you move to the left, however, this is the first time we're going to see end behavior where we're not going to negative infinity. X is approaching 0. If you were walking along this path headed in this direction, you can't really hop over the y-axis there. you're stuck on that curve and you're never going to get beyond an x value of 0. So that's why we say as x approaches 0, what's y going to do? Y is going to drop suddenly towards negative infinity. So there you have it, your domain, range, intercepts, x-intercept, the asymptote, and the end behavior for the function y equals log of x base 2. If the base changes, a lot of this stuff will remain the same. There will be some subtle differences if that base is a fraction, which we will look at in one of the triad problems coming up next. All right?